Hello everyone, my name is Anshu Kumar and I am one of the math experts here at QMath. We are the number one math experts community in India and we make learning mathematics fun. We at QMath enable our students to look at the why before the what of a concept, and all our students learn the concepts by working on them. So I welcome you all to our channel, the NCERT Class 7 Math, where we will be posting videos on concepts and questions of different topics of this grade. So if you like this video, do share it with your friends. Click on the like button below. Do subscribe to our channel and click on the bell icon. If you want a one-on-one live session with a QMath certified expert, check the links in the description. And if you register with the link, you will get one free live online demo session. So in today's session, we are going to discuss a very important and interesting concept of triangles, that is the Pythagoras theorem. Now, how many of you know that the Pythagoras theorem concept was found by a Greek philosopher, that too in the 6th century BC? His name was Pythagoras, so that this theorem is named after him. It's a very old concept, a very old term, but even today it has its relevance. Let us see how can we use Pythagoras theorem in real life applications. But before that, let us discover what is a Pythagoras theorem and how do we get to the Pythagoras theorem equation. Now, before we start, there is a very important thing about this equation, that is it can only be applicable to right angle triangles. Now, right angle triangle is a very interesting triangle because all its sides has certain names. For example, the side which is equal to the 90-degree angle is called the hypotenuse, and all the other two sides are known as the legs of the triangle. So basically, let us consider a right angle triangle with the hypotenuse C and the two legs as A and B. Now, let us consider four identical triangles such that we assemble these four triangles to form a square. Now, if we look at this particular figure, we see that there is an outer square and an inner square which is formed by these four triangles. Now, to find the area of one triangle, we know the formula is half times base times height, where in this case the base is A and the height is B. So the area of each triangle would be half times A times B, and if we find the total area of all the four triangles, we'll get 4 times half times A times B, which is equal to twice of AB. Now the area of the outer square would be A plus B whole square, because the side length of the outer square is A plus B. Similarly, the area of the inner square would be C square because of its side length C. Now, after this, we get to the relation that area of the bigger square is equal to the sum total area of all the four triangles plus the area of the inner square. If we substitute the values here, so the area of the bigger square is A plus B whole square, that is equal to twice of AB plus C square. Now, on the left hand side, if we use the formula of A plus B whole square and we expand it, eventually we are going to get A square plus B square equals C square. Now, think about it from where we started. So basically, we started with a triangle where the hypotenuse was C and the two legs are A and B. Eventually, we got A square plus B square equals C square. So from here, we get to the Pythagoras theorem statement, which is that for a right angle triangle, the hypotenuse square is equal to the sum of the square of the other two sides. So basically, this is the Pythagoras theorem, and this is the Pythagoras theorem equation. Now, let us see how can we apply this in real life scenarios. So for that, let us take this diagram where we see two pillars which are present on opposite sides of a road, and we don't know the length of the road, the width of the road, but we have a ladder whose length we know, and we also know up to what length this ladder can reach. I mean, that particular length is marked. So let's see on the whiteboard. I'll draw this diagram in a like a triangular form. Let's see what am I talking about? Okay, so as you see this skeletal diagram of the one which we just saw, so let me mark the things to make it clear to you. So basically, let us consider this AB and the CD to be those two pillars. EF is that ladder, and FG is the same ladder when it is placed on the pillar CD. So basically, we have been given that the ladder is 15 units. So EF would be 15, FG would also be 15. And if EF is placed on the pillar AB like this, as it is shown here in this diagram, then BE would be 9 units. And if the same ladder in the form of FG is placed on the pillar CD, then this GD length would be 12. Now, if we know these dimensions, it's a real life scenario, how can we find the width of the road? That's the question. So if we look at this diagram, the width of the road is nothing but BD. So if we can find the length of BD, we will be easily able to tell what is the width of the road. Here we also see that BD is a combination of two line segments. One is BF and the other one is FD. So basically, if we see the diagram, EBF is nothing but a right angle triangle. Similarly, GDF is also a right angle triangle, where we see that BF is unknown and so is FD. Now let's use the Pythagoras theorem in triangle EBF. Now the Pythagoras theorem says that the hypotenuse square, which in this case is EF square, is equal to the sum of the square of the other two sides, which in this case is EB square plus BF square. So basically, BF is the unknown quantity in this equation. Now EF square, we will substitute the value, so it becomes 15 square. EB square is nothing but 9 square. Let us keep BF square as BF square. So eventually we are going to get BF square equals 15 square minus 9 square, wherein 15 square is nothing but 225, 9 square is nothing but 81. So this is going to result in 144. So BF square is 144. So BF would be nothing but square root of 144, which in the end is nothing but 12 units. So now we got the value of BF, so we'll substitute it here. Similarly, let's again use the Pythagoras theorem in triangle FDG, which is again a right angle triangle, and here the hypotenuse is the FG, the side FG. So FG square equals FD square plus DG square. Let's substitute the values here as well. So FG square is nothing but 15 square equals FT square is the unknown, so we'll keep it as FD square. DG square is again 12 square. Eventually we are going to get FD square equals 15 square minus 12 square, which is going to result in 225 minus 144, and this is nothing but 81. So if FD square is 81, FD would definitely be a square root of 81, which eventually becomes 9. So let me substitute that as well here. So 12 plus 9 gives us 21 units, which is nothing but the width of the road. So if we have a few information about a few of the lengths, we can easily apply the Pythagoras theorem when we see there is a scenario of a right angle triangle. As we saw here, like we were easily able to find the width of the road using the Pythagoras theorem. Now, let's work on a small activity, which is kind of an application of Pythagoras theorem. So the question says that suppose there is a town A, which is like 8 centimeters due north. There is a town C, which is 6 centimeters due east. Okay. So what would be the shortest distance between town A and town C? Now you have the diagram in front of you. I won't be solving this question. I want all of you to just use the Pythagoras theorem and solve this question and post your answers in the comment section below. And we'll see like how many of you get the correct answer. And in case you have any other questions related to Pythagoras theorem, please post it in the comment section below. We will be very happy to answer all of them. So this was it for today's session. I hope that you liked it and you understood what is Pythagoras theorem and from where it came and what is its relevance. So if you like this video, do share it with your friends. Don't forget to click on the like button. Do subscribe to our channel and click on the bell icon. If you want a one-on-one live online session with a QMath certified expert, find the links in the description below. Because if you register with that link, you'll get a free online demo session. So do take care all of you, and I'll see you in the next video. Bye-bye.